All right, we're going to keep going. Unit 3, Lesson 4. This is the second part. Solving logarithmic equations. So let's say we've got the natural log of x equals 3. We would raise it to the power of e. So we would say e to the ln x equals e to the third. Again, these are going to cancel out, so you're left with x equals e to the third power. And you could type that into your calculator. So here we go. ln, let's call this part A, ln of x equals 2. Again, I'm going to raise it up. I'm going to use a base of e to the ln x, and anything I do on the left, I have to do on the right. So it cancels out. X equals e squared, which e squared is approximately 7.389. Let's say that I have log base 3, 5x minus 1 equals log base 3, x plus 7. So what I notice is that they are both the same base. So we are in good shape there. So we are going to use the one-to-one property and look at our stuff that's in parentheses because they are the same base. Log base 3, I can do this. So getting my x's on both sides, add 1 minus x, okay. Add 1, 5x equals 8, 4x equals 8, which means x equals 2. Part C, let's say we want to solve 5 plus 2 ln x equals 4. So again, I'm going to start by subtracting that 5. So I'm left with 2 ln x equals negative 1 by subtracting on both sides. I'm going to want to get rid of this 2 out front, so dividing by 2. So the natural log of x equals negative 1/2. And now again, to undo my natural log, I'm going to raise it to the power of e. So it cancels out. So x equals e to the negative 1/2. And when you type that into your calculator, you get 0.607. X is 0.607. Let's solve 2 log base 5 of 3x equals 4. I'm going to start by dividing this 2 on both sides. So I have log base 5 of 3x equals 2. Now again, because I want to undo this log base 5, because I only have it on one side, I need to put it into the exponent spot and use a base of 5. So log base 5 of 3x equals 5 squared. Again, these are going to cancel out, so I'm left with 3x equals 5 squared, which is 25. 3x equals 25. So all I need to do is divide by 3 and get x equals 25 over 3. All right, doubling an investment. This is when E is used a lot, is with interest. So let's say you deposit $500 into an account that pays 6.75% interest, compounded continuously. So that means it never stops. Every second, every millisecond, it's continuously compounding. Which, if you're an investor, you like that. So we can use the formula A equals P times e to the RT. Again, A is your account. P is your principal amount of interest, so your original amount that you invested. E is our letter E, and then R is the rate and T is the time. So when I substitute some numbers in, again, this is kind of my final value. I started with 500. My rate is 6.75%, which as a decimal is 0.0675. So 0.0675, and my time is well, we don't know what the time is. So let's say that we want to figure out how long is it going to take me for my account to get to $1,000. So instead of having it equal A, I'm going to say, all right, I want my account to be $1,000. Let's figure out what the time is. So 0.0675 T. So I'm going to start by dividing this 500 on both sides. So 2 equals e to the 0.0675 times my time. Now again, to undo e, I'm going to use the natural log. So the natural log of 2 equals, if I put the natural log of e, 0.0675t, this cancels out. So the natural log of 2 is 0.0675t. So all I have to do is divide 0.0675 on both sides. And I'm going to get approximately 10.27. So in about 10.27 years, my account that I initially invested $500 in would be worth $1,000. It doubled. And that's pretty cool because, again, you didn't do anything. You just had to put your money in a savings account, let it accrue interest, and after about 10 years, you have twice as much money as you started.